Hello, Algebra, and I am sorry that I am not here today, but I thought this would be the next best thing. I can be here for you, kind of, in a way, digitally. So what we're going to do is we're going to finish these two classwork papers I gave you last time. If you need an extra one, there should be some in the front. And if you remember, we did a little bit of this. We kind of went out of order. We did the bottom of this page first. If you look right here, we did these last ones about which of the following are examples of a function. So we're not going to really talk about those. And then we went back up to the top, and we started doing number one. And I showed you how to use the calculator in a really cool way to get your calculator to tell you the equation. So I'm actually once again going to show you with this first one, and then I didn't show you at all with the second one what to do, although it's very similar. So take a look at this table again and follow along with me. So if you haven't got a calculator, you can pause this, make sure you get a calculator, and then come back and start this again. Alright, so I'm going to get the calculator little app I have up. Let me clear it first before I bring it over. I had a different equation in that we're going to do later. Okay, so hopefully I can get it so that you can see it. Alright, that's good enough. You might not be able to see some of the times I hit enter or something, but okay, so in the not the y equals column, we want to go to the stat button. We want to enter in our own data. So we hit enter on edit, or hit number one. And I actually have different data, and it's actually for the next one. So I'm going to clear this. Clear this. And again, we want to just enter the data in just like you see it in the table. And that would be 1, 2, 3, 4 on the left. And on the right, it starts at 15, and then we said it goes up 16 every time. Oops. Oh, geez. Not 331. Clear. Okay, and then if you didn't remember what to do, once you get the table in there, we're going to go to Stat again, and we're going to go over to the Calculate section. So we calculate things based on the data we have entered. And there's a lot of stuff here. And all these things that start with end with REG, that stands for regression. And what your calculator can do is it can take a bunch of points on a graph and decide what kind of model fits those points best. And if all of the points are in a line and you pick linear regression, it's going to find the best line to fit that data. And our points are in a line, we decided because it was an arithmetic function, which is also a linear function. So we're going to pick, I'm not sure exactly what the difference is, I don't know what 9 does, but we're going to pick number 8 because it's in the format we want. So we hit the number 8. Right here it's asking which lists you want to use, and for most everyone that's list 1, list 2. I know there's a couple calculators where one of the lists was missing, so just make sure you're using the 2 lists that you want to use. If not, you can see right under right above the stat button, there's a blue button that says list. So you can actually go and hit that and change it to whatever list you want, but I don't want to change it, so I'm going to keep it on list 1. And then I'm not even sure what frequency list does. I'm not sure what that is. So, store regression equation. That might be useful, but I'm not sure. I've never used it. So we're just going to go to calculate. And it gives you to this weird window because if ever A or B was a really long decimal, this way it'll all fit. So this is what you want to actually write down. And the equation, they have it written backwards, so the bx and the a, we usually switch those. So the equation would be y equals 16x minus 1. And you want to go ahead and write that right in your y equals. So I'm going to write 16x minus 1. I'm going to go back to stat. Remember, anytime you can pause it. If you feel like I'm going too fast, just go back and watch it again or pause it. Hit stat again. We want to enter new data this time. So you can clear this data. And actually the next one, the x values are all 1, 2, 3, 4 again. So we'd only have to change this 2. And if you look, we're looking at the graph. We're looking at the y value of each point. And it looks like it starts at 3 and it goes up to 6, and it just keeps doubling each time. So 3, 6, 12, 24. And there it is. You want to go to stat again. You want to calculate. But this time, we will not pick a linear regression. It would be linear regression if these formed a line, and they clearly don't. Now the calculator will still pick the best line that fits that. It would kind of be like if you connected the first and the last one and then lowered it a little bit. That's what the line would look like. Instead, we're going to pick, because we know this is a geometric function, also known as an arithmetic function, we're going to pick, it's actually called expreg, or exponential regression. So this has many names. We've called it geometric. I think I'm missing one, but we're going to call it exponential probably from here on out. And it is actually number 10. You don't type 10 though, because as soon as you hit 1, it thinks you want the first one. You either hit 0 or move down to the 10th one and hit enter. So I'm going to type enter, because I can't even see my 0 button. And again, you want those two lists. Hit calculate. And this time it should look familiar. It should look like the geometric or growth function with the variable for x. So you'll want to write this one down. This is still part A. I'm going to write it in the y equals part. Let me get my key here. So we can hit y equals, down, and you can leave the other one there. And that's what we want to do. We want to leave the other one there and put the new one in so we can compare them. And that would be 1.5. Oh, I gotta move this up. Sorry if you can't see things for a minute. 1.5. You can either write times or parentheses. 2 to the x power. Alright, we want to compare the two tables. So let's go to the table, see where it's starting at right now. Starting at -3, which is fine. We really want to start it at 1. And part B says, which sequence will be the first to exceed 500, and how do you know? Well, I got to go down a little bit further to see. Neither of them are at 500, but I can see that the exponential function is starting to go up really fast. And you can see that it hits 500, somewhere between 8 and 9 hit it. So we would answer that part B by saying, maybe writing a little sketch. I actually wrote the table for 8, 9, and 10, and just wrote y1, y2, or I wrote a of n and y. It doesn't matter. And I just wrote on the side that since the red one right here is growing exponentially, then that function will definitely hit 500 first, and you kind of prove it with the table. All right, moving to the back number 3. There's a few things in here we got to fix. First of all of these part B, C, D, they should all have an F of in it. And I think even further below, this is supposed to be f of x equals 7. Alright, moving back up though, it says f, so the function is described as whole numbers to whole numbers. Assign each whole number to its largest place value digit. And then part A says, what is the domain and range of f? They give you a few examples of how this works. So they're saying, and this actually supposed to have an f in it too, f of 4 equals 4, f of 14 equals 4, and f of 194 equals 9. So what they're doing is they're taking the largest number, the single-digit number, in that whole number and saying that that's what the answer is. So the reason why f of 194 is 9 is because 9 is the biggest single digit in 194. So that's pretty easy. We can do these examples pretty easily, but like, what's the domain and range? So the domain, in other words, what kind of numbers can you stick in to x? In other words, f of what can you do? Well, you can do anything you want, as long as it's a whole number. So we'll say all whole numbers. In the range, we're a little bit more restricted on the range. So you could have a domain number that's like over 1 million, but there's still only going to be one of the digits that's the highest one. And the highest digit it could be is 9. The lowest digit it could be is 0. So anywhere from 0 to 9. So the range we can actually write, you can either describe it as a single digit whole number, or you could be a little bit more technical and say anything from 0 to 9 inclusive. So we can include those. And actually I used the y, but really we should be using f of x, since that's what it's giving us. So anything from 0 to 9 for the for the range. And then part B, what is f of 257? Again, the function tells us to just pick the biggest digit in there, so that would equal 7. Right here would equal 0. Here it equals 9. And then E asks slightly different. It says find a value of x that makes the equation f of x equals 7 a true statement. So what we want to do is put an x value in there where 7 is the highest digit, because that's the answer, 7. So there's lots of answers here. You could be really boring and just write x equals 7. You could say x equals 47. You could say x equals 1,237, something like that. But what you can't have is a number bigger than 7, because then it would equal that number. And then lastly, number 4, is the correspondence described below a function? Explain your reasoning. So again, this is the function I guess we're calling M. Women to people. Assign each woman their child. So that's the function, is if you're a woman, you are assigned to your children. So in our case, the domain is any woman, any woman, and then the range, now this time it's kind of flip-flop. The range could be anything, like any person. It's any person because every single person on this earth came from some woman, unless you came from a test tube or you were built with parts. But generally we can say that the range is any person. And is it a function? Well, can you think of a domain, an element of the domain, or a woman who would be assigned to more than one element in the range, or a person? I can think of my mother, who is assigned to 4 children, and I am the 3rd one of 4. So this is definitely not a function, and you probably have your own example of why this is not a function. Alright, that takes care of paper 1. We're going to get the other paper out and learn how to do set builder notation.